Good morning to all. Myself Chakrodhara Joy, Department of Physics, Bankura Samilin College. Now I am going to discuss about the virtual lab on bipolar junction transistor to draw output characteristic in its C mode of connection. Okay. Actually, virtual lab is a computer-based activity where students interact with an experimental apparatus or other activity via a computer interface. Okay, so let's see the circuit diagram of bipolar junction transistor in C mode in virtual lab. See here, this is the circuit diagram of the bipolar junction transistor in C mode, and this is the transistor. We know transistor has three terminals: base, emitter, collector. This is base, this is emitter, and this is collector. And the arrow sign in the emitter indicates the direction of the current, and we know the direction of motion of the positive charge indicates the direction of the current. So the positive charge are moving from base to emitter. So base is doped with p-type impurity, and at the same time we can say the emitter and collector doped with n-type impurity. So it is the NPN transistor, and also there is another type of transistor, and this is PNP transistor, but always we prefer NPN transistor. Okay. We know the normal biasing condition of the transistor is the input junction is always forward biased and output junction is the reverse biased. Okay. So for the forward biasing of the input junctions mean base to emitter junction. Here this is the battery and this is the variable resistance. By changing the resistance, we can apply different voltage across the base to emitter terminal. That means the input terminals. Okay. And for forward biasing of the input junction, the positive terminal of the battery is connected to the base and negative terminal of the battery is connected to the emitter. And so this is the input loop, and in the input loop there is a voltmeter and an emitter, and this voltmeter is used to measure the input voltage across the input terminal. Okay, and it is the micro emitter. Actually, it is used to measure the base current. Actually, base current is very small, because the doping concentration of the base is very small. Okay. Now for the reverse bias of the output junction, this is power supply, and positive terminal of the battery is connected to the collector and negative terminal of the battery is connected to the emitter. Okay. And in the this is output loop, and in this loop there is a voltmeter. This voltmeter is used to measure the output voltage across the output terminal, collector and an emitter. And this is the emitter. It is used to measure the collector current. Okay. And since in the circuit diagram there is two loops, input loop and output loop, and in both the loop emitter is common, so it is called the common emitter loop. And also there are two types of mode of connection. Another mode of connection, common collector and common base. But always we prefer the common emitter mode of connection because of different number of advantages. Okay. Now I will draw the output characteristic. Actually, output characteristic is the variation of the output current with output voltage for fixed value of the input current. Here input current is the base current. Actually, it is the current control device, so we have to fix the input current. Now fix the input current first by changing the resistance. Almost the input current is fixed at 10 microampere. Okay. Now we have to apply the different output voltage at the output terminal. So point 1 for 0.1 output voltage, the collector current is 3.290, and to recording this data in the table we have to click add to table. Just click here. Okay. So 0.100 collector to emitter voltage gives 3.290. Again use another voltage 0.4, add to table. This gives 12.54. 0.6, this gives 17.73 milliampere current. 0.8, add to table. this gives 21.92. Already show the reading in this ammeter. Now apply 1 voltage. Okay, add to table. This gives 26.42. (1.2) add to table. This is 27.52. Current become almost constant. Okay. Actually, transistor come into the active region. Now apply 1.6. Okay, 13 point. Current become almost constant. Now I want to draw the output characteristic. So for drawing the output characteristic using this data, we have to click at the plot option. Okay, so this is the output characteristic. In the same way, we can draw the output curve for different base current. Again, we have to choose the different value of the base current by changing each one resistance, and in the same way, by applying different output voltage here by changing RH2, we will get the different collector current. Okay, so let's see the curve. When the collector to emitter voltage is smaller, then the current is increases, but at certain time become constant. Actually, there are two regions. This is the saturation region and this is the active region. Okay. Actually, transistor acting in the three region: active region, saturation region, and cutoff region. Okay. When the transistor input junction and output junction both remain in the forward biased condition, the transistor acting in the saturation region, and when both the junction remain in the reverse bias condition, then the transistor works in the cutoff region. Cutoff region means the transistor become off. But when input junction is the forward bias condition and output junction is the reverse bias condition, then the transistor works in the active region. Okay, in that region. In the active region, the current is slightly increases. This is due to the early effect. Okay, what do you mean by early effect? Early effect, actually, when the output junctions means the base to collector junction. When the base to collector junction is reverse biased, then the depletion region at the output junction become widened and spread into the base. So the effective base width increases, and that is why recombination is decreases and collector current slightly increases. So the increase of the collector current in the active region due to the early effect. Okay, actually transistor is a nonlinear device, but in the active region transistor become linear. So when transistor used as an amplifier, we always operate the transistor in the active region, and since it is nonlinear, so biasing is very important. So there are also different type of biasing for operate the transistor in different condition. Transistor also operate as a switching device. For switching device of the transistor, we have to bias the transistor in the saturation region and cutoff region. But for the amplification action of the transistor, we have to bias the transistor in the active region. Actually, for stability of the amplification, the linearity of the transistor is very important. So biasing is very important, and different type of biasing are there, and I will discuss about the biasing of the transistor in the next class. Okay, thank you.